Good morning. At this point in time, I'm probably, as most of you know, on a bus right now, or to Tillamook, darn close to getting there, I would imagine, for a very long day at a middle school track meet. Anyway, hope that I got a couple sections here I want to cover with you, 4.5 and then 5.1. Sure Eric is helping you out with the with any questions that you may have. Just a reminder, projects are due today. You have some lab time to go in there and work on those if you need to finish them up. You're just sending me the link, so when you go into Desmos, you'll send me the link when you're completed with it and send it to my email. Make sure everything is there. You should have, again, 6 polynomials. That's what we're looking for, and they can't all be those 6 polynomials. We don't want it to be lines. They need to be of more than just lines. They need to be curves, second degree, third degree polynomials, whatever you have. And if you're still not sure about it, there's videos on the DTL site. I think there's a Math 95 Activity 1 Part 1 and a Part 2, which talks of Part 1. I think just kind of goes over some of the basics of it. Part 2 is showing you how to use Desmos to do some restrictions and just kind of get some basic to do the restrictions, I think, and was to kind of complete how to download an image and put an image on there if that's what you choose to do. The ones that I've seen so far, I think people pretty much just did their own thing, which is certainly okay. So anyway, enough about that. Let's kind of get going here with our topic today here. So we have complex fractions is what we're going to do. So we've been talking about rationals quite a bit. We've went ahead and did operations on them, and we solved them. Hopefully that went well. And now another part of rationals is this thing called complex fractions. So it sounds a complex fraction. Fractions are hard enough as it is, right? That's what most people think. So how can we make them more complex? Well, they really aren't doing anything to make them more complex, all right? So basically a complex fraction is just a couple of fractions being divided, okay? So if we have something like this, say, that's a complex fraction. All right, so we're just taking 3/4 and dividing by 5/8. So we know, I'm going to write this out, that's what that's what that means. Okay, when we have the bar here, that's division. Okay, and we know that when we divide fractions, we're going to flip, right? Flip and multiply. Okay, so now we can do this, right? And we can just multiply straight across if we want to, or we can do some canceling out here and get the answer that way. So let's see, then we have a 6/5. All right, so that's what a complex fraction basically is. Let's look at some more. Of course, that's kind of just something to lay out an example of it. The title would be Simplify on these. And don't be afraid to pause this or ask, hey, can you pause it at any time? All right, because that's I want you to do that. These videos, both of them, aren't going to take very long, so take your time, pause them anytime you want. Make sure you get all the information that you need. Ask questions, so forth. All right, so let's do some more here. Okay, so we'll introduce some variables now, right? But the idea is still the same, right? So we're just going to have this. We're going to multiply. We're going to flip this. I'm just going to flip it right away. Instead of writing that division down, I'm just going to multiply and flip. All right, now I can reduce. So can't do anything with that, but I reduced these x's down. So this x is gone. I have 1x on the top, and I have 3 over there. Okay. All right, so there's my answer. I can't do anything else. It's simplified. That's it. Alright, so let's try some more here. Stepping up the game a little bit. Okay, so now we have a complex fraction that looks like this. So we have 2 plus 1 over x over 2 minus 1 over x. So here we're still going to do the same thing, but first we should deal with the top and we should deal with the bottom. Well, what do I mean by that? Well, we can add those fractions, or we can add these two terms. Alright, so I want to take the top here and say, well, let's see, this is really 2 over 1, right, plus 1 over x. So I learned that I can add those two rational expressions because I need to put an x on this side where the 2 is. I'm going to multiply this 2 by an x. Alright, so now I have that. So basically what I did is I took this 2 over 1, right, I multiplied by x and multiplied by x because that is what's over here. And then we talked about that last week. Getting common denominators sometimes has us, let's look and see what's on one side of the fraction, or the expression I should say, and let's see what's on the other side, and then we can decide which way we're going to add, okay, or what we need to multiply. So I multiply by an x because I need an x, because I have an x here. Of course, I don't need to worry about the 1. So this is now done. Alright, so now I'm going to do the exact same thing on the bottom. Okay, again, I put this guy over 1, and I say, hey, I just have to multiply that 2 by an x. So I have 2x minus 1 over x. And now I'm going to go ahead and flip and multiply. Okay, so I'm dividing, but now I'm going to take and multiply. I'm going to flip this so it looks like this. And x's are canceling. You're saying, was everything good? Is it always going to be where something cancels? Most likely. Not always, but most likely. And there it is. Alright. And we talked about how we can't cancel the 2 x's, right? That's 2x plus 1. That's a 2x minus 1. We can't cancel the 2 x's. So we are done with this problem. But it's a little different than the other one. The other one we just went ahead and flipped and multiply. On these type, we need to work the top, work the bottom, and then we can flip and multiply. Okay, this here we'll do this one. Alright, same type of problem though. Okay, we got a top here that we have to deal with and a bottom. And we always want to do that first. Alright, get it so that you get that common denominators, get the top added up, get the bottom added up, and then flip and multiply. So, here we have a 2x here. This is over 1. So I'm obviously going to need a 2x here. So I'm going to multiply that, so that gives me 4x squared minus 1 over 2x. So I don't do anything with the 1 because it's already over 2x. That's the common denominator. So I don't have to do anything with that. Work on the bottom. Same thing. Multiply by 2x. So I end up with 4x squared minus 1 over 2x. Right? 4x squared plus 1 over 2x on the bottom. So now here's where I'm going to flip and multiply. So I'm going to take this here. Okay, multiply, remember I'm going to flip. Alright, now I see right away 2 x's are going to go away. Okay, however, nothing else is going to cancel. But just to be sure, because you don't know what's going to happen on some of these other ones coming up, I would take this and factor it anyway. It's a difference of 2 squares, right? So if we factor it, we should get this. Alright, 2x's are gone, so I'm not going to do anything with that. And then I have 4x squared plus 1 on top. Can't factor that guy, because it's not a difference of two squares. Can't factor it. So then here's my answer. Okay? Now, we probably didn't have to factor that because it didn't really do anything for us. So we could have left the problem answer like this. Okay? Same thing, it's just written a little differently. Had we been able to cancel something, then we could have been able to do that. Okay? But in this situation, we couldn't. But I think it's something you need to be aware of, is that you probably want to think, hey, if I can do some factoring there and something cancels out, I want to make sure I do it. Because you are simplifying, so it's got to be in the simplest form. Alright, let's try another one here. Same thing, making it just a little bit harder though. Ah, the complex part's coming in, huh? Okay, so now we have a problem like this. Again, we're going to have to add the tops, or work with the tops, work with the bottoms, flip and multiply. So here's my top. Alright, I'm going to add these two fractions. So I've got x minus 1 over on this side. I got an x on this side. So we're going to multiply this side by an x, multiply this side by x minus 1. That's going to be my common denominator. Alright, there we go. Now I can distribute that, and I okay, so then now let's work on the bottom. So we'll do the same thing, right? So we'll multiply this side by x, multiply this side by x minus 1. So I'm going to get x plus 3x minus 1 over this denominator here. Alright, now let's go ahead and flip multiply. So I got 3x, so I'm going to distribute that inside. Alright, so it's going to give me 3x minus 2x plus 2 over x minus 1 x times, right, flip, x minus 1 x. So I'm going to get 3x here minus 3. And I would probably combine these ones here. But again, I'm just kind of showing you the steps, right? So x plus 2. Don't change this. That's going to cancel anyway. Right? There. And 4x minus 3. Cancel, cancel. And there's our answer. Alright. So again, complex fractions there. We're going to work the top, work the bottom, get those common denominators. Not much different than what you were doing last week, except now it's kind of taken the one problem, made it into two. And if we can simplify things at the end, which we couldn't, that's it. But we definitely could cancel things. All right. Let's see. I'm looking at some problems here on the assignment, and you'll get some time as usual to work on some stuff. So, and if you have any questions, you can probably get some answers. Let's see. I think they'll be okay with those. I think you'll be okay. Let's just try one like I'm looking at number 28 here. So let's try one like that. Okay. Take a look at it here. 5 plus 1 over x minus 1 over 1 over x minus 1 minus 1 over 4. So it looks like that. Okay, so here we go. Common denominators, right? Not anything again. We're going to do work the top, work the bottom. Put this over 1. Multiply x by x minus 1. This time, this one has, oh, look at this. We got a 4 here. We got an x minus 1 there. So we need both of them. That time we actually need to do both sides. So let's see. What do we get on the top here? We got, let's just go ahead and distribute this. So we have 5x minus 5 plus a 1 on the top over x minus 1. That's my common there. Here, let's go ahead and distribute this one. So 1 minus x plus 1, because you got to distribute that into both of those, right? Oops, this is a 4. Huh, catch me on that one. Let's see, then I got 4x minus 1 on the bottom here. Okay, now we're going to flip and multiply. So let's see, I have 5x, and I think this is supposed to be a, what did I do here? Oh, 5x minus 5. All right, so that's going to be a minus 4 on the top over x minus 1. Flip and multiply. 4 goes there, x minus 1 there. 5 minus x on this one. And x minus 1s are going to go. So we still have this 4 left over, so that's got to go to both of those. Over 5 minus x. All right, can't simplify anything, so we're done with that. Okay. I think you'll be all right with the complex number ones. But if I guess if you have questions, you'll ask me. All right, so let's take a look at okay, 5.1. 5.1's kind of a repeat of what maybe you would have had in Math 65 if you took that last quarter or whenever recently. It's about radicals and roots. Okay, so like in Math 65, you talk about a square root. All right, the fact that a square root of b squared equals b. All right, but also understand that it could be equal to negative b, because negative b squared is b squared, very much like b squared is also b squared. Okay, so in other words, when you take the square root, you get something called the principal square root. And that's the one that you think of. So for example, if we talk about the square root of 4, we know that that is 2. Why? Because 2 squared is 4, right? That's called the principal square root. So when you use a calculator, that's what you're going to get. That's the kind of the positive number is the one that you're going to think of in your mind. It's also the one your calculator is going to give you. That's called the principal square root. However, because of the fact that we're squaring, it's also true that it could be a negative 2. And again, that's because you can square that and get 4. So a square root has actually a positive and a negative answer. All right, so but the positive answer is called the principal square root. Okay, so square roots. I think in 65 we made a little chart and I wrote them all out. 1 and 4 and 9 and 16 and 25 and 36, 49, 64. Let's see, 81. Of course, 100. All right, and if you square root those, you're going to get this. Okay, and that's how that works. Okay, so if that helps you, great. That's your square roots. All right. Again, those are your principal square roots. If they're going to ask you to evaluate approximate, anything along those lines, calculate, that's when you're going to use your calculator, right? So square root of, for example, 18 is equal to, take your calculator, okay? Actually, here, let's do this. Let me show you. Let's see here. I'll go into Desmos here. Oops, I think I just cleared the dang thing right out. There we go. Okay, so square root right down there. Put my 18 there. It tells me it's 4.2426. It's going to go on because that's an irrational number. Most of your square roots are, of course, unless you get a nice one like square root of 36 is 6. Okay, so that's not. But most of the time you're going to get square roots that are just going to go on. Those are irrational numbers. So I would write down 4.2, what was it, 4.2. So I'll just put point. And they'll probably tell you where this one here, like I'm looking at in the book, says thousandths. I kind of like going to hundredths or tenths, depending on the situation. So for me, you can stop right there. Alright, so I'm just kind of looking through some stuff here. Those are your square roots. Alright. If we want to take the square root of a negative number, say a negative 8, alright, and we're looking for a real answer to that. We know that there is no real answer for that one. You can't take the square root of a negative number. Alright. I know that in 65 and some of your previous mathematics experiences, you know that there's an imaginary number out there and that allows you to take the square roots, but that's an imaginary number. We're talking strictly about real numbers here, so we're not going to consider the imaginary numbers at this point. Alright, so there's our square roots. Of course, we could have cube roots, right? And the idea there is, if we have the cube root, they'll symbolize that by a little number there. 8 is equal to 2. Why? Because 2 to the third is 8. Okay? So 2 times 2 times 2 is 8. That's why it's called a cube root, because it's 3 times the expansion of multiplication there. All right, so that's a cube root. Unlike square roots, you can take the cube root of a negative number because negative 3, negative 3, negative 3 gives us negative 27. So we can have positive and negative square roots of cube root. I mean, you can take the cube root of a negative number, sorry, and you can take the cube root of a positive number. Those aren't going to be plus or minuses. It will depend upon the sign that's inside the radical, right? So if it's a negative inside the radical, then your answer is going to be negative. If it's a positive, then it's going to be positive for cube roots. And you can go on. I mean, there's fourth roots and fifth roots and so forth. You can do whatever you want. Okay, so if we have a fourth root, it's going to be symbolized by that. Okay, let's see. Let's do one here. Let's go with I think 256 is a perfect fourth root. Let's check it out and see. I could be wrong, but I'm pretty sure I'm right. So we'll come down here. I'll get rid of that. Now, to do a root that is not a square root in Desmos, all right, we need to go to the functions thing here. And let's see, I think it's under miscellaneous. Oh, yeah, there it is. Right there. There's the root with a little n. So I'm going to put that there. All right, so I'm going to put 4 there because that's my root. And then put my 256 in there because that's the number I chose. And how about that? I get 4. Okay, so fourth root. So in Desmos, I'm just going to use the functions here, right? Miscellaneous, use that little root with the n there. That's going to give me what I want. Okay. All right. Again, with the fourth root, it could be plus or minus because It could also be a -4, since -4 times -4 times -4 times -4 gives us 256. Alright? So the fourth root of 256 could be a positive or a -4. The 4 is obviously your principal root. So there's many different roots you could do. You could go ahead and use your calculator on that. Some of them, I think, might ask you, if you to not use it. All right, in which case you'd have to kind of just know your powers and your roots, kind of like what we have up here. All right, I didn't put cube roots in here. All right, but you could. I mean, you could really go out and say, okay, these are my square roots. Now next to this, I'm going to put my cube roots in. All right. So let's see, this is 625. And then now I'm going to start. Now I need some help. Oh, wait a minute, I'm doing cube roots, aren't I? Hold it. Back it up here. Still on the fourth root. So this would be 64. And this would be 125. And, oh, I'm not sure. Maybe 216. Yeah, I think it's 216. And now I'm stretching my knowledge of cube roots. So this would be your square root here, right? And this would be your cube root, or your cube. I probably shouldn't use a root. So this would be like x, this would be like x squared, and this would be like x cubed. Okay? Alright, so those kind of help, I guess, if you need to use a little chart there. Alright, you can probably fill it in with the rest of the numbers. I'm thinking that 49 is something 343, 343, I believe it is. It just kind of came to me. Okay. Alright. So there's that. And now, let's see, what are they asking us to do here? They're just having you find some square roots. For example, I see one that kind of looks like this. Alright, so what's the square root of that? Well, this square root and this square are going to undo themselves, give you x plus 1, and they're going to say, hey, but it has to be absolute value because it has to be a positive number in order to work, right? Because you can't take the square root of a negative number. At least we know that it can't be a real number, so that's why they put absolute values around that to say, hey, that's just got to be positive. Okay. They also have one like this. I've never been too crazy about these, but this can be rewritten in this form if we factor it. Okay. So again, undo themselves, and we're left with x minus 2. Absolute value because it's got to be a positive. So you're going to see some stuff like that on your assignment. All right. Man, I'm just looking for stuff here that, again, if you had math95, you're in pretty decent shape, and I don't think there's any here. Let's go ahead and do this. Let's talk about the domain of a square root function. So let me go ahead and put in square root of x. I'm going to go y equals here. I want to. There we go. There's our y equals. So remember, domain, right, is going to be x's are what we input into the function. We can input 0 into the function. We can put anything after 0, but we can't put any negatives in there, right, because it's a square root. So we would say the domain of this is going to be all positive numbers. Right, so domain of y equals the square root of x is going to be x is greater than or equal to 0. Okay? Alright. Well, what if we change it a little bit? Okay? So, for example, what if I put a number out in front? Right? What will that do to it? So I'm going to go back into Desmos here. Okay? I'm going to stick a number out in front of that. I'm going to put an A in there. I'm going to introduce a slider. Alright? And let's play with this a little bit. So we see here, is that changing the domain at all? And you should say, no, it's not changing the domain. It's still starting at 0. Still going on to infinity. So, no, it doesn't change anything. Alright. Well, let's take that A move it, put something inside. I'm going to go with get rid of that darn thing. I'm going to go with an x minus a b, okay, and add a slider b. So I don't need a slider a anymore. So how about this? Well, I can see right away, hey, wait a minute, this is no longer starting at 0, it's starting at 1. So then my domain is going to be greater than 1. And as I increase this, I can see that that's moving, right? So that changes my domain to whatever's inside there. Same thing if I go backwards, I can see that that's changing my domain. All right, so yeah, if this here, domain doesn't change, right? But as soon as I put a number inside the square root like this, all right, then it depends upon what b is. Now we have to be careful, because if we have x minus 3, for example, you might say, oh, well, that graph's going to shift back 3. But it really doesn't, right? It's going to shift over 3 in this direction. Okay, so it is basically what b is. All right, since this is a minus and this is a minus, that's your b. So then your domain is going to be x greater than or equal to 3. Now, if it's a positive number inside there, so for example, if we have an x plus 5, then what that means is that my b is negative, because this would be a negative here, right? In order for that to happen, I'd have to have this situation, right, where b is a negative number. So, oh, okay, here we go. So now I'm going to go back to negative 5 and draw my curve a little thicker than I wanted. That's my default here on the tablet. So let me erase that whole darn thing. There's this. This is going to be a negative 5. So now my domain is x is greater than or equal to negative 5. Alright. And if they're asking us for range, I'm not sure that they are. Let's check to see if they are. Nope, just talking about domain. Alright. Then that's all you have to worry about. Okay. So I really don't know if there's a whole lot in the 5.1 that's going to completely mess you up. I see one like this I probably should mention. So we haven't done anything like this yet. If we have the cube root, say, of x to the 9th, okay, then this is going to be, well, not x to the 9th. Yeah, this is x to the 9th. That's going to be x to the 3rd. Okay. Anyway, well, how is that? Well, that's because x to the 3rd, right, times x to the 3rd times x to the 3rd is x to the 9th. Okay, well, what's really happening here? Well, what's happening is we're taking this 9 and we're dividing it by the 3, which is the root. Okay, so that gives you that power of the answer. All right, so if we have, for example, the 4th root of x to the 8th, then really all I need to do is divide those two, and I get x to the 2nd. All right. So, so that's it, I guess, what I'm going to say there. I think you'll be okay with the rest of these. I'm looking at them. I see evaluates, I see approximate, simplifying, which is pretty straightforward, and then just using some evaluating by sticking the x values into for x. So, and then finding domains. So I think you'll be okay with that. So I would just go ahead, and at this point you can do some of the problems off there. And if you have any questions, Eric will help you out. And then I'll be seeing you next Saturday. If you have any questions on anything, don't be afraid to email me. I'll be able to talk to you. So good luck and have a good week.